All right, let's help you get problem 77 set up on page N of Chemistry 1128. And then there's actually a problem 78 that is very, very similar to 77 that I think you can do on your own. But let me kind of walk you through the steps here to get 77 going. There's a formula covered in this section of the PACE, and it's called the free energy. And you say, what does G have to do with free energy? Well, that's a good question. They kind of run out of, I think they run out of letters. Actually, the guy who came up with this formula, his last name was Gibbs. And so sometimes this is called the Gibbs free energy. But that doesn't really matter. G means free energy. And if, when we solve this entire equation, where we involve the enthalpy of formation, and we take into account the temperature and the entropy. And if we take all that into account, if the delta G ends up being a negative number, then that means the reaction is likely to occur in nature. If it's positive, then it means it contradicts the laws of thermodynamics and is not going to happen spontaneously. Okay? So just because we put two elements together, or put two chemicals together, does not mean that they're going to react. But this formula helps us determine whether it is likely under these conditions that it will indeed happen. All right, so let's take problem 77. It says calculate the change in free energy of the reaction involved in the production of ammonia. So that's NH3. From nitrogen and hydrogen at 500 degrees Celsius. And the question they want us to answer is the reaction spontaneous? So we're first, so it's a yes or no question, but don't just guess. We want to find the answer to solving this formula for this information. So I'm not going to do this for you. I want you to look up table 8.1, find ammonia. Write the number down. Be sure you keep track of whether it's positive or negative. Delta S, you're going to look that up from table 8.3. Write that down. Make sure you keep track as well, positive or negative. Then, don't forget, it's 500 degrees Celsius, but for this equation, it has to be in Kelvin. So you have to convert 500 degrees. How do we do that? Do we add 273, I think it is? Add 273 to the Celsius and you'll have the Kelvin. All right, once you have those three numbers, you have three variables here, you're going to plug that into this equation. So you'll have delta HF, the temperature in Kelvin, times the delta S, which is a decimal number, and then you subtract. Now if this is a negative number, and you're subtracting, then remember when you subtract a negative number, you're actually adding. So this delta G may end up becoming a positive number. It may be a negative number. If it is negative, then we would answer yes, that the reaction is spontaneous. If you end up with a positive number, then you would say no, it's not spontaneous. All right, after you've done that, number 78, you're going to set it up the same way that we did. Write down your three givens, your delta H, look up delta S on table 8.3, convert the temperature to Kelvin, write down the formula, solve the formula, being very careful about your negative numbers, and then you're determining yes or no. Yes or no, is it a spontaneous reaction? Okay, I don't think you'll find that to be too hard, and hopefully this little lesson helps you feel confident that you can do these problems.